Good evening, welcome. Let's look at the question 9.1. The event A and B are mutually exclusive. It is given that probability of B is equals to true probability of B, the probability of A will be equals to 0.57. So what do we know about mutually exclusive events? We know that probability of A and B is equals to 0 because the events are mutually exclusive. Now, question was calculate probability of B. Then what do we know? We know that probability of A or B it is equals to probability of A plus probability of B. In this case, by given that probability of A it is equals to probability of A. So now, in other words, we can divide this by 2 to say that probability of A it is equals to probability of B over 2. Now let's come back to the formula here. Probability of B it is equals to 0.57. It is equals to probability of A, which is probability of B over 2 plus probability of B. Now this is over 1. Yes. Now what do we do in this case? We can multiply by the denominator of 2. So it's going to be 0.57 times 2. It is equals to probability of B plus 2 probability of B. In this situation, so we have what is 0.5 times 2. Situation we have it as 1.14. It is equals to 3 probability of B as we're going to enter plus 2 probability of B. So we divide both sides by what? By 3. So probability of B in this case is equals to 0.38. Now let's look at 9.2. There are 5 loaves of brown bread, 7 loaves of white bread, then brown represented by B, white by W, bread on the shelf at a local supermarket. The two clients, one followed by the other, each randomly select a loaf of bread from the shelf and put it in their basket. 9.2.1 determine probability that the first client will take out the loaf of white bread. So now we're looking at the probability of choosing white. Remember that probability is a number of event divided by sample. The sample, we talk about how many things are given. Situation, how many loaf of bread are given? With 5 plus 7, 12. Then by how many are white? 7 are white. So probability 7 over 12. That's a probability. 9.2 to assume that the owner of the shop doesn't replace any loaves of bread on the shelf after the client has taken the loaf of bread. Determine probability that both clients will take out the brown bread. So what happens if it's without replacement? The probability of choosing brown bread for the first time, it will be 5 out of 12, because now the person have to choose 5 out of 12. But the probability of choosing the brown bread for the second time, now in this brown bread, we have removed 1 loaf here already, so I left with 4. Remember, without replacement. So if we're taking out, we choose out of 4 because 1 brown is out. But how many loaves are there remaining now? 11. So choosing this, because it's brown and brown, it's going to be 5 over multiplied by 4 over 11, which in this situation is 5 over 12 multiplied by 4 over 11, which this makes it 5 over 33. Okay, let's look at the next question. If the first client take out a loaf of white bread, the owner of the shop places a loaf of brown bread. So you see, choosing white, he places brown. With the other loaves on the shelf, if the first client chose brown, the owner will places white with the other loaf. So that means that this is replacing the loaf of bread, meaning that loaf of bread remains 12, but what's going on is if you chose white, he places brown. You chose brown, he places white. So now let's look at determining the probability that the loaf of white bread and the loaf of brown bread is sold to them to clients. Now what's going to happen is, let's look at this in the tree diagram. How many branches? There are 2 branches because there are 2 choices been made. So the first client might choose brown or might choose white. So now if he chooses brown, going to choose brown. How many browns? Remember, brown with 5 out of 12. Or you can choose white. How many whites? 7 out of 12. But there's something going on here, is that if he chose white, if he chose brown, what's going to happen? Brown was chosen, so we have 4 browns left, but the owner have replaced brown with white. So that means that the loaf remains as 4 as 12, but now you have added white. So how many whites are here? We have 8 whites out of 12, because this is going to be choosing of brown, choosing of white. But now what happens? If you choose white, the owner will replace with brown. So if choosing white, brown will never been chosen. So I'm going to add 1 of the brown, which is going to be 6, but the loaf remains as 12. So but now in the situation, the person chose white. So what's going to happen? Then the white went down to be 6, but the number of bread left with 12. So this brown is going to be white. So they determine probability that the 2 clients chose white bread and brown bread. So there's no order of which one was chosen first, but we know that this one is brown and white, this one is white and brown. So there's no order on how this can be chosen, which one was chosen first, but we are looking at this. So in other words, we can say the client might have chosen brown and then white, or can be chosen white and then brown, and all means positive. Brown and white means multiply. So what is the probability of choosing brown? Of choosing brown is 5 over 12 multiplied by, of choosing white is 8 over 12, plus of probability of choosing white first is 7 over 12, and probability of choosing brown second is 6 over 12. Why? Because now choosing of brown replaced with white, and choosing of white replaced with brown. So what is the probability in this situation? 5 over 12 times 8 over 12 plus 7 over 12 over 12. So our probability of here will be 41 over 72 as the probability that he will choose the brown and white. Now look at 9.3. 9.3 says every morning the father has to drop his children off at school on his way to work and pick them up again on his way back or on his way home from work. There are 3 different routes from home to school and 5 different routes from work to school to work. Can the father travel from his home to work? Remember now, he's traveling from home to school, so from home to school, ways 3 roads, so you can choose out of 3 roads. Then after work, he can choose out of 5. So this is 15. So 9.2, this is 0.1. Traveling from home to work, then back to his home. Now let's look at this: home to school, school to work, and from then school to. Now let's start with one. How many roads from home to school? How many roads from school to work? 5. Then how many roads from work to school? 5. How many roads from school to home? 3. So this is 3 by 5 by 5 by 3. Then how many roads? This is 3 by 5 by 5 by 3, which is 225 ways of travel. And 3. Now traveling from home to work, then back home, if he does not use the same road twice. Now let's focus on this. Therefore, he can't use the same twice. No, there's no repetition. Here, the repetition choice remain the same. Now he's it's going to move from home to school. Now, he never used any of the road, so from home to school is the choices, from school to work is choices. Now, is this makes them 15 choices, but now from to school, out of the 5 roads that he had, he used 1 in the morning, so now he's left with 4. From school to home, he used 1 in the morning, then he's left with 3. This makes it altogether is 3, 4 by 2. Then that is 3, 5 by 4 by 2, which is 120 ways of traveling.